Hello and welcome to today's episode, which deals with the concept of project management and the various methods of project selection. In this episode, we shall be covering the following topics: project management and project selection. I am Dr. Sabiha Khan, teaching in the Center for Management Studies, Jamia Millia Islamia, New Delhi. Before we start this topic, let's understand what is project all about. According to Project Management Institute, a project is a temporary endeavor undertaken to create a unique product or service. The concept of project came from armed forces. They used to come out with building small bridges, tunnels, buildings, etc. Now these days, from advertising campaign to election campaigns are the class examples of project management. Recent development and popularity of metro is another example which has shown us how a project is executed well in time with all quality standards is maintained. Every project is divided into various parts like tasks and work unit, for which task force came into picture for execution of the work on time. Another aspect of project management is to monitor all activities with optimum utilization of costs and resources. Every project has its unique life cycle, and each phase of its life cycle has to be observed carefully by the project head, as he needs to appraise it to its top management or to the client for which he had taken up this assignment. Now, if we carefully observe the life cycle of the project, we can make out maximum efforts are required at conceptual, selection, planning, scheduling, monitoring and control level. Rest is appraisal or the evaluation part. There are three phases of project management: planning, scheduling and controlling. In order to visualize the sequencing or precedence requirements of the activities in a project, it is helpful to draw a network diagram. The various steps are as follows. Number 1. Identify various activities, tasks or work elements to be performed in the project that is developing breakdown structure. Number 2. Determine requirement of resources such as men, materials, machines, money, etc. for carrying out the activities above. Number 3. Assign responsibility for each work package. The work packages corresponds to the smallest work efforts defined in a project and form the set of element tasks which are the basis of planning, scheduling and controlling the project. Fourth, allocate resources to work packages. Fifth, estimate cost and time at various levels of project completion. Sixth, develop work performance criteria. 7. Establish control channels for project planned. Once all work package, that is tasks, have been identified and given unique names or identifiers, scheduling of the project, that is when each of the activities required to be performed is taken up. The various steps are as follows. Number 1. Identify all people who will be responsible for each task. Number 2. Estimate the expected duration of each activity, taken into consideration the resource required for their execution in most economic manner. Number 3. Specify the interrelationship among various activities. Number 4. Develop a network diagram showing the sequential interrelationship between various activities. For these steps, such as what is required to be done, why it must be done, can it be dispensed with, how to carry out the job, what must precede it, what has to follow, what can be done concurrently may be followed. Number 5. Based on these time estimates, calculate the total project duration. Identify critical path. Calculate floats. Carry out resources smoothing or leveling exercise for critical resources, taking into account resource constraint, if any. Project control refers to evaluating actual progress against the plan. If significant difference is observed, then scheduling and resource allocation decisions are changed to update and revise the uncompleted part of the project. In other words, remedial or modifying planning or reallocation of resources or cost minimization measures is adopted in such cases. According to a research, 30% of all projects got cancelled in midway. Half of the completed projects are over budget by 190% and 220% are late. When project undertaking organization goes beyond their expertise and resources and goals, failure to deliver by the outsourcing organization will also lead to this situation. Hence, project selection is an important aspect of project management, where the process of evaluating the individual project and then choosing to implement some set of them so that organization goals are achieved. Choosing a set of project is a difficult task. Reasons for failure are high due to the following reasons. First, delay in one project will lead to other project delay as resources are shared. Second, lack of optimum utilization of resources. Third, lack of specific resource or technology for projects. Coming back to the model of project management, following was suggested by Souther in 1973 for the success of the project. Realism. The model should reflect the reality of firm's decision situation, especially the multiple objectives of both the firm and its managers. Keeping in mind that without a common measurement system, direct comparison of different projects is impossible. It should also take into account realities of organization limitations and facilities and other resources, market risks, performance, cost, time, implementation and customer rejection. Capability. The project model should be capable to deal with both internal and external to project, strikes, interest rate changes, etc. Flexibility. The model should give valid results within the range of conditions that the organization might experience. It should be easy to modify in response to changes in the firm's environment. Ease of use. Model should be convenient and should not take a long time to execute, easy to use and understand. Cost of data gathering and modeling should be low. There are two types of selecting models, numeric and non-numeric. The various types of numeric models are payback period. The payback period is the length of time required to recover the initial cash outlay on the project. In this, the initial fixed investment in the project is divided by the estimated annual net cash inflows from the project. The ratio of these quantities is the number of years required for the project to repay its initial fixed investment. For example, if a project involves a cash outlay of rupees 6 lakhs and generates cash inflows of rupees 1 lakh, rupees 1,50,000 and 2 lakh in the first, second, third and fourth years respectively. Its payback period is 4 years because the sum of cash inflows during 4 years is equal to the initial outlay. According to payback criterion, the shorter the payback period, the more desirable the project. Firms using this criteria generally specify the maximum acceptable period. The more the project. Firms using this criteria generally specify the maximum acceptable payback period. If this is n years or less, are deemed worthwhile. The projects with a payback period exceeding n years are considered unworthy. Evaluation. A widely used investment criteria, the payback period seems to offer the following advantages. It is simple, both in concept and application. It does not use involved concepts and tedious calculations and has few hidden assumptions. It is a rough and ready method for dealing with risk. It favors projects which generate substantial cash inflows in earlier years and discriminates against projects which bring substantial cash inflows in later years, but not in earlier years. Now, if risk tends to increase with futurity in general, this may be true. The payback criteria may be helpful in weeding out risky projects. It emphasizes earlier cash inflows. It may be a sensitive criteria when firm is pressed with problems of liquidity. The limitation of the payback criteria, however, are very serious. It fails to consider the time value of the money. Cash inflows in the payback calculations are simply added without suitable discounting. This violates the most basic principle of financial analysis, which stipulates that cash flows occurring at different points of time can be added or subtracted only after suitable compounding or discounting. It ignores cash flows beyond the payback period. This leads to discrimination against projects which generate substantial cash inflow in later years. It is a measure of project's capital recovery, not profitability. It measures a project's liquidity. It does not indicate the liquidity position of the firm as the whole, which is more important. Discounted payback period. The major shortcoming of the conventional payback period is that it does not take into account the time value of money. To overcome this limitation, the discounted payback period has been suggested. In this modified method, cash flows are first converted into their present values by applying suitable discounting factors and then added to ascertain the period of time required to recover the initial outlay on the project. The payback period may be regarded roughly as the reciprocal of the internal rate of return when the annual cash inflow is constant and the life of the project is fairly large. The payback period is somewhat akin to break-even point, a rule of thumb. It serves as a useful shortcut in the process of the information generation and evaluation. The payback period conveys information about the rate at which the uncertainty associated with the project is resolved. The shorter the payback period, the faster the uncertainty associated with the project is resolved. The longer the payback period, the slower the uncertainty associated with the project is resolved. Decision makers, it may be noted, prefer an early resolution of uncertainty. Discounted cash flow, also known as NPV method, where the discounted cash flow method determines the net present value of all cash flows by discounting them by the required rate of return. NPV of a project is the sum of the present values of all the cash flows, positive as well as negative, that are expected to occur over the life of the project. The general formula is NPV of a project is equal to A naught plus summation T ranging from 1 to n, Ft divided by 1 plus K raised to the power T, where Ft the net cash flow in the period T, K is the required rate of return and A naught is the initial cash investment. Because this is an outflow, it will be negative. To include the impaction or deflation, where P is the predicted rate of inflation during period T, we have NPV of a project is equal to A naught plus summation T ranging from 1 to n ft divided by 1 plus k plus pt raised to the power t. Early in the life cycle of the project, net cash flow is likely to be negative, the major outflow being the initial investment in the project. If the project is successfully, cash flow will become positive. The project is acceptable if the sum of the net present values of all estimated cash flows over the life of the project is positive. The net present value represents the net benefit over and above the compensation for time and risk. Hence, the decision rule associated with the NPV criteria is accept the project if the NPV is positive and reject the project if NPV is negative. If the NPV is 0, then it is a matter of indifference. Despite its advantages and direct linkage to the objective of value maximization, the NPV rule has its opponents which point out some limitations. NPV is expressed in absolute terms rather than relative terms and hence does not factor in scale of investment. The NPV rule does not consider the life of the project. Hence, when mutually exclusive projects with different life are being considered, the NPV rule is biased in favor of the long-term project. The internal rate of return of a project is the discount rate which makes its NPV equal to 0. Put differently, it is the discount rate which equates the present value of future cash flow with the initial investments. If we have a set of expected cash inflows and cash outflows, the internal rate of return is the discount rate that equates the present values of the two sets of flows. Problems with IRR. There are problems in using IRR when the cash flows of the project are not conventional or when two or more projects are being compared to determine which one is best. In the first case, it is difficult to define what IRR is, and in the case, IRR can be misleading. Further, IRR cannot distinguish between lending and borrowing. Finally, IRR is difficult to apply when short-term interest rates differ from long-term interest rates. It is also known as benefit cost ratio. The profitability index is the net present value of all future expected cash flows divided by the initial cash investment. Some firms do not discount the cash flows in making this calculation. If this ratio is greater than 1, the project may be accepted. Benefit cost ratio BCR is equal to PVB divided by I. Net benefit cost ratio is NBCR is equal to PVB minus investment divided by investment is equal to BCR minus 1, where PVB is the present value of benefits and I is the initial investment. Evaluation of profitability index. The proponent of benefit cost ratio argue that since this criteria measures NPV per rupee of outlay, it can discriminate better between large and small investment and hence is preferable to the NPV criteria. It is also referred to as average rate of return on investment is a measure of profitability which relates income to investment, both measured in accounting terms. Since income and investment can be measured in different ways, there can be very large number of measures for accounting rate of return. The measures that are employed commonly in practice are A. Average income after tax divided by initial investment. B. Average income after tax divided by average investment. C. Average income after tax but before interest divided by initial investment. D. Average income after tax but before interest divided by average investment. E. Average income before interest and taxes divided by initial investment. F. Average income before interest and taxes divided by average investment. G. Total income after but before depreciation minus initial investment divided by initial investment by 2 into number of years. Obviously, the higher the accounting rate of return, better the project. In general, projects which have an accounting rate of return equal to or greater than the pre-specified cutoff rate of return, which is usually between 15% and 30%, are accepted. Others are rejected. It is very difficult to generalize if the accounting rate of return is calculated on the basis of average income over the life of the project. However, if the accounting rate of return is calculated for each year using the expected or actual net income, the following generalizations may be made. The accounting rate of return tends to understate the internal rate of return for earlier years and overstate it for later years. The accounting rate of return and the internal rate of return can be the same only if the depreciation schedule is equal to the economic depreciation schedule. Inflation and creative accounting tend to create a discrepancy between the accounting rate of return and the internal rate of return. Evaluation. Traditionally, a popular investment appraisal criteria, the accounting rate of return has the following virtues. It is simple to calculate. It is based on accounting information which is readily available and familiar to businessmen. It considers benefits over the entire life of the project. Since it is based on accounting measures which can be readily obtained from the financial accounting system of the firm, it facilitates post-auditing of capital expenditures. Which income data for the entire life of project is normally required for calculating the accounting rate of return, one can make do even if complete income data is not available. For example, when due to indeterminacy of project life a complete forecast of income cannot be obtained, the accounting rate of return may be calculated on the basis of income for some typical year or income for the first 3 to 5 years. The other profitability models are a great many variations of the models just described. These variations fall into 3 categories. Number 1, those that subdivide net cash flow into the elements that comprises the net flow. Second, it includes specific terms to introduce risk or uncertainty, which is treated as risk into the evaluation. Third, those that extend the analysis to consider effects that the project might have on other projects or activities in the organization. Operating necessity. If the project is required in order to keep the system operating, the primary question becomes, is the system worth saving at the estimated cost of the project? If the answer is yes, project costs will be examined to make sure they are kept as low as is consistent with project success, but the project will be funded. Competitive necessity. Investment in an operating necessity project takes precedence over the competitive necessity project, but both types of projects may bypass the more careful numeric analysis used for projects deemed to be less urgent or less important to the survival of the firm. The next is the product line extension. In this case, a project is to be developed and distribute new products would be judged on the degree to which it fits the firm's existing product line, fills a gap, strengthens a weak line or extends the line in a new desirable direction. Next is comparative benefit model. For this situation, assume that an organization has many projects to consider, perhaps several dozen. Senior management would like to select a subset of the projects that would most benefit the firm, but the projects do not seem to be easily comparable. Next is real options. Recently, a project selection model was developed based on the notion well known in the financial markets. When one invests, one foregoes the value of alternative future investments. Economists refer to the value of an opportunity foregone as the opportunity cost of the investment made. That is the end of this session. Hope you had an informational session on project selection. Goodbye, take care.
Thank you.